Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Perseids from Perseus. So what do we see here? Well, here we see an image looking at some of the Perseid meteors from this past meteor shower just a few days ago. And this is not what you would see all at once. This is what you would see over a longer period of time. At about its peak, you might see about one or maybe two in a minute. So we're looking at a very long time frame here to get this many meteors visible in the image. Now, the meteors themselves are actually tiny bits of material, debris left behind in the orbit of a comet, and that is known as Comet Swift-Tuttle. And that comet orbits around the sun with a period of about 133 years. Now, its last appearance was in 1992 and will not return again until 2126. However, the debris left behind by the comet continues in the same orbit. It follows the same orbit that the comet did. So particles left behind from previous visits still continue to orbit around the sun with that same 133-year period, and over time they fill the entire orbit. So when Earth happens to pass through that part of the orbit of the comet, then we get a meteor shower such as the one imaged here today. Those tiny bits of debris, mostly just grains of sand type size, will then hit Earth's atmosphere at very high speeds and vaporize. These never make it down to the surface of Earth. They won't come down to Earth. They burn up very high up in the Earth's atmosphere and leave just this trail across, and the debris just becomes part of Earth. Now we can note that if we trace all of these meteors back, they seem to be coming from one point in the sky. That is what is known as the radiant point of the shower. And the radiant point is where they all appear to be coming from. Now in reality, these bits of material are all traveling parallel through space. But because of the perspective looking out from Earth, they appear to converge off in the distance. So just as railroad tracks or telephone poles will appear to converge off in the distance on a straight road, then you will see the same kind of thing here. They're appearing to converge, but it really is just telling us that they're following that same orbit through space. Now, this year's Perseid meteor shower was unusually good. That's because the moon at the time was a new phase of the moon, meaning it wasn't visible. And the moon, while it doesn't directly affect the meteor shower, what it does do is brighten the sky. So if you get the Perseids around the time of full moon, that's going to brighten the sky, and many of the fainter ones that you see here would simply not be visible. However, on a very dark night like this, where no moon is visible, even more meteors were visible than typically would be seen. And of course, that new moon also corresponded to a solar eclipse that we've looked at pictures of recently that occurred around the same time as the peak of the Perseid meteor shower this year. So that was our picture of the day, titled Perseids from Perseus. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.